Hi everyone, I'm Kevin Miller with DAV, and joining me today is Alex Berardo-Cates from VA's innovation team, and we're here to talk about a little bit more about his work and what they got going on over there. So thanks for joining us today, Alex, and tell us a little bit more about your work.
Yeah, so I'm a development engineer with the VA Office of Health Innovation and Learning, and I work for a team that designs, develops, and manufactures medical devices within VA. And we make a variety of devices, but here today I'm showcasing our initiative that we're calling digital prosthetics. And that is a supported, standardized framework for enabling our prosthetists to access digital manufacturing technology. And what I mean by that is access to 3D scanners, access to digital design tools in the prosthetic space, and 3D print. And we're doing this because our veterans are requesting access to the latest and greatest technology, and we want to be able to make sure we have the infrastructure necessary to support that. And the timing is good, you know, in the industry in general, so inside the VA and outside the VA, people are not broadly adopting these tools just yet, and they're really needing that support and that framework for process controls to standardize these processes so that you can achieve the same kind of results that are equivalent to standard of care or better than standard of care, no matter where you are.
Great, and can you tell our folks at home some examples of how they make a difference in the day lives of veterans?
Yeah, sure. So I think it's important to highlight the current standard of care. So right now, standard of care looks like plaster-based molding and casting. And this process is iterative, it's slow, but it is the standard. People are able to achieve this. This is how they're trained. And the other side of that is that the data is lost. And so just at baseline, having a record of how the limb is changing, how the residual limb is changing, how the socket design is influencing that residual limb, and being able to track longitudinal changes could make a big difference here when we start implementing some of these tools and technologies. What does it look like for the veteran? It looks like being able to be perhaps engaged differently in your prosthetic care, to be able to pull a historic record of, hey, this is where I was, this is the one that really fit well, I'd like to use that as a starting point, or say, hey, I've got a pain point right here, this is where I want it addressed. Be able to look at a model digitally, physically, and use the historical record to be able to use that as a starting point to have maybe a better first socket, or maybe your veteran are changing locations, changing providers. We want to be able to facilitate better handoffs by leveraging that record. There are all kinds of different scenarios we can get into. Someone breaks a socket or breaks a device on the fly. We have a record that we can immediately print and replace. So the opportunities are really there. Now, what we're doing now is demonstrating the capability, providing that support and framework so that we can prove that the opportunities are real.
Great, that's so good to hear. And then you talked about some of the iterative design process. What kind of other specific data points are being collected from the improvements that you guys are making in this process?
Yeah, so, well, we're looking at time efficiencies. We're looking at quality improvements. So where we get veteran feedback here is absolutely critical. We want to know at what point does the veteran want to have a say? Where do they feel like their voices are most powerful in this process? How does this process influence delivery times? It may make no difference in a lot of cases. It may make a lot of difference in a few clinical scenarios. We want to better differentiate where that stands, but the opportunities are absolutely there.
Great. And so earlier you mentioned how this is expanding access to care for veterans, both inside the VA and outside the VA. Can you, let folks know how this initiative is expanding access to care, and specifically for below-the-knee amputees?
Yeah. Well, first of all, I want to be really careful because I know that veteran access to care is absolutely controlled by these clinical service lines. We're here to support them, and we're providing new tools to be able to support clinical providers to offer the best possible care they can. Where we see this having an impact is in being able to lower the footprint, lower the facility requirements necessary to provide this kind of care, to facilitate, like I said before, better consultation, better handoffs between clinicians. So maybe this looks like having having a VA facility where you have a small footprint that may not allow for the plaster rooms that's necessary, which are dusty, the big machinery that's necessary for fabrication, but instead they are outfitted with 3D scanners, with software licenses, smaller footprint, lightweight, low facility requirement. And we think by providing this supported, standardized framework, we can maybe improve and expand access to facilities that aren't able to currently provide care, maybe, or to be able to improve efficiencies at places that already do provide that care.
That's great to hear. We always love to hear that care is being expanded for our veterans, especially our veterans with disabilities and amputations. And so what are some of the benchmarks you guys have set, or what have you seen how the broader industry has responded to some of the innovations that you're currently working on?
Yeah, thanks for that. This is a great question. How is the industry responding? I guess I'll start with that. We're not doing this alone, right? We're not reinventing the wheel. We're not starting from scratch. We're working with industry partners that have already made progress in this space. However, this has been a promise. 3D scanning, 3D printing has been a promise in the prosthetics industry for some time now. What's missing is that support, that standardization, that framework, and that's what we're really offering here. Some of the milestones that we're looking to achieve in the near term in accordance with that is in demonstrating within different sites across the VA network that we can do this, that we can have good handoffs, that we can meet certain quality standards, that we can deliver timely, high quality care that is at least equivalent to the current standard processes or better. And that comes from making sure that we can meet the OIT requirements. That it comes to training the prosthetists so that they feel like they can achieve the same results that they can currently achieve with standard of care. So our milestones, to get back to that, by the end of this summer, we will have demonstrated our capabilities within 3 different sites and our home base, which is in Seattle, so Vision 20 area. And we will have trained clinicians shown that we can deliver in both the digital workflow aspect, so training and scanning, digital design, and 3D print of the device at those sites. And we expect to be able to engage in some veteran feedback. What we need is more veteran feedback now and always into the future. By the end of the calendar year, we hope to wrap up the initial set of demos, and then by the end of the next fiscal year, we expect to be able to release an early version of this workflow for VA.
Great, that's great to hear. Before we let our members know how they can potentially get involved, or if they're in need of some prosthetic devices through VA Innovation, can you show us some of the examples of devices that you've previously printed out and demo for our audience?
Sure. Yeah. Let me start with the process kind of as it goes. So for your members that have or are currently wearing prosthetics, they'll probably be familiar with the check socket. So this is a 3D printed version of a check socket. The beauty of this is it can be made in under 3 hours, which means it can be done on site within an appointment, and it's completely heat modifiable and can be ground to be customized for the veteran. And this starts that digital record. So you have the 3D scan of the limb. You can modify that. You can make changes to the shape of that limb to be able to transfer loads in the areas of the anatomy that can handle those loads, and offload areas that can't handle those loads. From there, you make that check socket. You go through that iterative fit process, having like a tailor-made device. This can be modified. Once that modification is captured digitally, we can move on to designing and fabricating a definitive device. So right now, this would be a very simple version of a prototype, right? It looks a lot like a carbon fiber device. And this is 3D printed with a powder bed technology. And it is vapor smoothed so that it has, similar properties to the carbon fiber. Now, the benefit of this, what we're really working towards, is being able to create novel designs. So this is kind of an early prototype, but the direction that this is going is in the customization features, and being able to personalize these devices with your military branch, with your family members, with your favorite band, whatever excites you, right? Or to personalize it with different color options, right? Something like this, where we can emboss your design, you can paint it as you saw before, or maybe in future versions we'll be able to add color into the print itself. And so this personalization is incredibly powerful to the veterans that we've talked to so far. We want to know how we can better exploit this so that they can get the devices that they want. Hidden in this, though, which you're not seeing because you'd have to see a cross-sectional view, is all of the kind of engineering that goes into making these strong and reliable. And so we've done a lot of work to ensure that certain design parameters are maintained in order to ensure minimum safety and effectiveness requirements.
That's great to hear, and I love to see all the customizable, designs within the different prosthetics here. And you did mention briefly that it takes only about 3 hours to, make these devices. In comparison, how long does this take to like the traditional, prosthetic process to make one of these devices to let, our folks who might not be as familiar with, securing a device like this?
Yeah, that's a great question. So this one takes about 3 hours, and the timing depends. So right now the current standard of care is you'd take a plaster impression, right? And from that you would go into the back of the shop and into the prosthetics lab, and you would grind that plaster mold down. You're familiar with this, but maybe many of your members are not. And what you're doing there is relieving certain areas of the plaster mold so that you can affect how the load is transferred onto that limb. Now that process may take an hour, may take 2 hours, may take 15 minutes, depending on the prosthetist, the kind of needs and requirements of the amputee. Now in our digital process, we're leveraging data and historical records to be able to get to this point much faster, like within 15, 20 minutes. And that means that you can get to the fabrication part much sooner.
Gotcha.
Now from there, once you have a digital model that's fully what we call rectified, where the reliefs are made on that model, you can send it to a carver and you can vacuum form a check socket, the kind of more traditional way, or you can send it to the printer. And what's faster, that kind of depends on the prosthetist and the setup in that lab, but results will vary. This is just an option to be able to do this digitally. Now, once you get to this point and the shape is finalized and you want to create the definitive socket, that will take about a week to fabricate. So that's, the timing of that is more similar to the carbon fiber equivalent.
Excellent. And last to wrap up, you did mention that you are potentially looking to pilot and demo this in your area in Washington. So if we got any members in the Washington area who are interested in potentially getting fitted for a device like this, comment in the links in the chat, and we'll put you in touch with Alex to find out more. And Alex, can you also mention some of the other locations that you're potentially expanding to in the next year? So folks in those areas, to make sure you monitor, follow along, stay tuned throughout the year, and see if these opportunities come to your area. So Alex, what are the few other VAs that coming
So
to?
currently we're fully supported in Vancouver, Washington, near the Portland, Oregon area. But we're also starting to spin up training and our demo sites in Orlando, Florida, in Columbia, South Carolina, and in Minneapolis, Minnesota.
That's great to hear. So appreciate your time, Alex, today. And thank you so much for your work you do, and we'll see you around.